Yeah? All right, let's get into a demo, yeah? And then let me first start with, I wrote the pages and timed out. Yep, obviously. Let's start with the new assurance overview at the org-wide level, and then let's see that what we got from the brand new navigation pages, right? Come on. All right. Demo guard. All right. So typical view that we got is this new wireless overview. I'll skip that. Then you have clients, you have wired and wireless and network devices, application, and infrastructure. I love this part most. The LAN and WAN and VPN and RF. So I know that this is a wireless session, but if you look at the LAN, then it consolidates all the information a lot from the layer 2 of the switch level. The what switches struggle to get sort out the broadcast and multicast traffic, how many VPN channels that you have, and how many of them are up and down, what's their performance look like, what's the usage consumption, and so on, yeah? You get all this data from the one pages. And then RF, I will save it for the next topic because RF optimization, they have a lot to cover this part. And then applications. So it's all good, yeah? But the point that I want to go over, maybe this one too, yeah? On the client, you can get into every single one and then see that if there's any specific client failing most. This is probably best tool to identify the one client that keep bamming our APs and the network that try to associate it. So like, for example, this kind of things, right? This client doesn't have a proper, credential, so it keep denying, and then you keep attempting it. By the way, we have added the client exclusion function in R32. So you'll be able to do it, but it's manual. It's not like a dynamic exclusion like a controller. But we have that. Let's get into the organization view that I was just mentioned. This is a new pages, organizational summary. And then this new summary view, yeah, welcome to the new landing page experiences. This page just went out to public beta last week. So many of you guys may have not seen it before. So it starts to show the device availability because we heard that this is the most common and number one item. Just show me the green light and red light. And then tell me about my entire organization. So across all my organization, things are looking fine, controller, access point, and the WAN appliances. There's a 2 offline. Check out what it is. Okay, there's a 1 teleworker, 2 teleworker devices. They get disconnected. So then I can find out who is this guy. Just simply click that. It'll switch off to that pages. Then I can see that who they are, what to do. Probably they haven't really connected after they received it. And then in this view that you have multiple ways to navigate it. So it's a network with the most score drop from the last time, or I can check out how's my overall network look like as an overall hash score, the ranges of the hash score, and see that what component is impacting most. So in these cases, this teleworker version 2, we have a network device score is a 10, it's pretty low. Why is that? Because of the utilization, and I can see a trending view. Why is that? Because it has 100% usages, yeah? My WAN traffic trunk is fully occupied. I have to extend my WAN trunk. But yeah, this is a wireless session. So let's go back to our wireless here. And then let's see that I want to check out certain client failures. So in this case, San Jose, client score is 90. Why is 90? Why is not 100? Yeah, because there's a one wired client. It looks like there's no wireless problem today. I know why. Because every Cisco guy is in San Diego. We don't have much guys in the SF today. Yep, and what happening on this client? Yes, the client is not able to forward because of the client policy. The user may have some bad things in the past, right? NAC comes in, then they isolate it from the network. So from the organization level to the single endpoint failures, just one click, right? And you can go back into the summary, just with go back navigation, pretty powerful, yeah? All right, let's look at the client view here. So let's try to troubleshoot the client. Let's go back to assurance view and see what we have got here. And then, come on. Oh yeah, okay, I'm on the different, it's not a demo problem. It's on the Televoco network who don't have any demo, who don't have any client, so that's why. So let's go back to our SF12 office and then see what have got in the last 2 hours. The wireless client, a couple of failures happening, association. It's mostly transient issues. I will get into more on the transient, but let's look into detail. So I have a 9 client failed to connect. There was a couple client can't receive the DHCP. Yep, there's a OWE, guest network. Yeah, this is typical. My most of the guest SSIDs is quite transient, so we don't send particularly, but this Meraki Corp, yeah, they got the DSP NAC. Why this is happening, yeah? Let's look into that. So zooming in, and now I have a good old view. This is what we have used before, right? And then right now it's connected. I have to go to the timeline view and then convert it to the bed. Yep, DHCP server rejected. So this is what you have today. So pretty much of why the clients are not getting the IP addresses and the DHCP NACs happening. Which VLAN they are on. Okay, RSSI is pretty fine. It's not an RF problem, not a policy problem, but the client is insisting to get a new IP addresses. I mean, keep the old IP addresses. So this is what we have. Let's look at what it looked like in the brand new client 360. Click new version. Let's see what we got in the new version. So this is a brand new view. The same client, it experienced the periodic failures, right? Right now it's all okay. And then, yep, it doesn't have IP addresses with 6, but with 4, yes. The what MAC address look like. This information used in the bottom of the pages. So we got some feedback from customer to bring it up. So I need to get the MAC and IP address. It's easy to access and easy to identify. And then where they are, I mean the location, and then overall topologies. So was RSSI, SNR level, was a type. This is the Chrome OS. This, I think, the wall board. This is one of the WebEx Room OS devices here. They connect on the wireless, yeah? And then what type of network policy they are using, what type of firewall policy they are using, so it's all good, yeah? But in this case, we had a DHCP problem, right? DHCP issue that you got. So what is the latest DHCP issues here? So zooming in. Yep, client rejected because DHCP server rejected the DHCP request. So I know that this condition is when it happened, how it happened, and it's not about the switch issue, it's not about the application issues. So it pretty much, I mean, got much more expanded view than what you have. So what you found from this exercise, right? This is much more organized, structured, combined, and insightful, in my view. But there's more, right? There's more. What we have missing is the PCAP. Can I have a PCAP data on so that I have a hard proof, evidence? Yes. Let's look at this client. This is the my iPhones that tucked into my bedroom. And then it has some interesting issues. I have authentication, association, DHCPs, all going on, right? So let's get into the association, because association is a pretty, it's a transient issue. And then often it's very hard to understand why my association failed. So let's click this failed event, zooming in and see what we've got. Yep, client failed to connect momentarily. But with unknown reason. There's no specific evidence that why client disconnected and failed to join. Feel familiar? Yep. So in this case, what we have is the brand new AI PCAP analyzers. Let's turn on the AI PCAP analyzer and learn what we have. Yep. AI analyzer, I was zooming in here for everyone's benefit. AI systems, we have, Cisco we're in the process of building digital model of transmission and PCAP. Essentially, if the LLM understand the languages, can we have an AI model that understand your protocol? That's this AI PCAP model. Now that the PCAP analyzer can be done by AI, it literally explains what had happened on the client association one by one at every single packet by packet. That's what we called the reasoning processes. Throughout the reasoning process, thank you. Throughout the reasoning process, we are going through every packet by packet, reading what it is and how it is, and describe what had happened in human languages, readable English. And then I know that people, younger generation, including me, even I am gray, don't want to read too much. So what we built, the brand new packet timelines. Pretty sick, right? Thank you. And then this entire view is available in the form of a traditional packet viewer. Yes, we have integrated AI analyzer with a packet viewer together. So in the traditional way, what would you do? I need a highlighter, right? Let's mark it. Which packet is bad packet? Turn on highlighter. AI system go through every single packet and see if there's any failures. In these particular cases, I particularly brought most challenging scenario where I don't have any failures. So system couldn't find any misnorm. But if you look at these things, there's some interesting movement is going on. There's a lot of action frames, from the client. And why that it is, let's read it through. The wireless client network shows a client attempt to the lab 1 SSID with WPA3. Initially, it was successfully associated, all done. However, during the reassociation process, AP denied because there is excessive frame loss or poor channel condition. Client reattempting association successfully, complete full handshake. Despite that, there's ongoing connective issue, repeated probe request and action frame, radio measurement. So this is all indication of the client is not in the good RF coverages. So this is protocol problem? No, this is an RF problem. And you can actually get that. Why? Because our system actually include all the radio header from every traffic by traffic. We have a radio header information. This is from the AP. Let's get that from the client. So we know what is their RSSI look like from the AP point of view. And imagine that you have this packet analyzer at every protocol. Every single network protocol. Now the AI models will tell you what goes wrong and what possibly happens in the particular past histories. Because every time you have a failures, you have a PCAP, and not just PCAP, you have an AI model that tell you what specific condition exchange, what information element was wrong, and then you can pinpoint, you can download, and you can forward it. Now you have your companion, right? That's the intelligent capture today.